Okay, so for today's lesson, we're going to be looking at graphing sine and cosine day one. So with day one, we are going to just start with what do the basic parent function graphs look like for sine and cosine, and then kind of do some basic transformations with them, shifting left and right, up and down, and then some reflections. So to start, if we were going to graph something that we did not know what the graph looked like, so if I wanted to talk about how does the cosine graph or the sine graph look, how would I start? Well, I would start by making tables. So if we are going to be graphing y equals cosine of x, we need to get some points so that we can make a table. So when we think about trig functions, the easiest x values, which here are going to be angles to plug in, are going to be the quadrantal angles. Those give us numbers like 1, 0, -1, undefined. So to start, let's look at the cosine table. If we were to evaluate where x is 0, so that would, I'm going to come down here if we're looking at y equals cosine of 0. So if you evaluate cosine of 0, well, 0 falls right here. That's our ordered pair, 1, 0. Cosine, we're looking at the x value. So 1 will be what you get there. Now moving on to cosine of pi over 2. Pi over 2 falls right here. And that ordered pair is 0, 1. Well, the x value there is 0. Now if we move on to y equals cosine of pi, pi falls right here at -1, 0. Again, cosine is about the x, so that's -1. And then we're looking at cosine at 3 pi over 2, which falls right here. 0, -1, again, all about the x, that's 0. Then we're at cosine of 2 pi. Well, that's going to be the same number we get when we evaluate cosine of 0, which is 1. So this pattern will just continue, and we'll see what this looks like on a graph. Okay, we're going to do the same thing if we were trying to graph y equals sine of x. So we're going to plug in those quadrantal angles and see what we get for these values when it's sine. So let's see, if we're evaluating y equals sine at 0, well, we just saw that the ordered pair was 1, 0. Sine is all about the y, so the y value there is 0. Then if we evaluate sine of pi over 2, that falls up here at 0, 1. Again, all about the y values, well, the y value is 1. If we evaluate sine of pi, y is 0 at pi. If we evaluate sine of 3 pi over 2, well, y is -1 there. And then back to 2 pi, that's going to be the same one as 0. So we're back at 0. Okay, so we generated our table. And now let's plot these and see what the graph for this first function is going to look like. Y equals cosine x. So when we talk about graphing these, so you have your table from the last slide. I am going to take these ordered pairs and graph them. Okay? So if you look at this, our x values are going to be these angles. So that's how we label our x-axis. So I am going to start, and we have pi over 2, pi, we had 0, but that's right there, 3 pi over 2, and then 2 pi. So when we were graphing cosine, we saw here that when x was 0, y, because this is really going to be our y value, which was cos x, is going to be 1. So that's our first point we're going to plot. Then at pi over 2, our y value will be 0. And then we saw from the table at pi, our y value is -1. At 3 pi over 2, our y value is 0, and then at 2 pi, our y value is 1. Okay, this is one period of the graph, and we'll get more into that verbiage tomorrow, but with the next lesson, but that is one period of the graph. How long does it take to go from top back to top of the graph? Because sine and cosine graphs are just a continuous wave, okay? So this is going to continue going, and that will go back down and finish those. So let's do another period to the left. So I'm just doing the negative of these angles. And it's just going to follow the same pattern. Notice it goes top, middle, bottom, middle, top. So here we're at the top. It's going to go back through the middle, back to the bottom, back through the middle, back to the top. And there is our parent function for the cosine graph. Pointing out a couple things here. Because we're going to be using the parent function for to do the remaining graphs for today. So we think about the parent function as our starting point is at x equals 0. So this graph starts at the top, okay? And then the rest flow from there. So we'll see how that can maybe move, your starting point can shift, etc. Okay, I'm going to do the same thing with the table we made for sine. So we use the same angles, 0, pi over 2, pi, 3 pi over 2, and 2 pi. Now the way sine started, if you go back here, we started at 0, 0. Okay, so 0, 0 falls right here. Then the point pi over 2, 1 is up here, pi 0, 3 pi over 2, -1, and then 2 pi 0. So here's one period of the sine graph. So what happened here, we started in the middle, we went through the top, through the middle, back through the bottom, and back to the middle. That's also another way to measure the period of the graph. So I will continue this and graph another period to the left. And it has to match that same flow. So if I look at this, we ended in the middle, but I was at the top here. So we were top, middle, now I have to be at the bottom, middle, top, middle. There we go. Okay, so there are the parent functions we're going to be working with. So I want you to save these and use these for these next few problems that we're going to graph together. And all we're doing to these, or we're going to be applying the transformations. Okay, so here's number 3. We have y equals sine negative x plus 1. So we're thinking about the sine graph. And what transformations we're doing here. This negative x is going to change the sign on all the x values, so that will reflect it over the y-axis. If you change the signs on the x, you're going over the y. And then this constant at the end, that means we go up 1. Okay, so remember, we always translate first. We always translate last, so we do our reflection first. So, let me just put a couple starting points here. So if we go back to this graph, we just use kind of these first points here. We'll apply the transformations just for this first one. So, I'm just going to put little x's here. there's the parent function. I'm just going to apply the transformations to these points, and then I'll continue the pattern for the remaining points. Okay, so we talked about the reflection over the y-axis. Let's start with that point right there. If I reflect that over the y-axis, nothing changes, and then we shift it up 1. If I reflect this point right here over the y-axis, I'm now at negative 2 pi. I'll go ahead and complete this because that's going to shift them all. Okay, so if I reflect over the y-axis, here I am, and then if I go up 1, I land right there. Here, if I reflect this and go up 1, I land right there. If I take this point right here and I reflect it, I land right here, and then I go up 1. Last point, I reflect over the y-axis and I go up 1. So, there is part of our graph, and that is one period of the graph. Now, just to set you up, we are going to be graphing 2 periods of sine and cosine graphs. So I'm going to continue this pattern. So we have a point in the middle right here. We went top, middle. My bottom points are falling on the x-axis. We can see that bottom point right here. And then I'm going back to the middle, top, middle. So then it's going to continue like this. And there's 2 periods of the graph. Okay, there's example 3. We have 2 more examples, so go to part 2 video to see the last 2 examples.